Okay, so before we went to lunch, we talked about the fact that dimensional analysis, and the official math definition might be a little bit more complicated than this, but we're basically just going to say for right now, it's when you take the units into consideration. So when we talk about units, we're talking about feet, we're talking about inches, we're talking about yards, pounds, ounces, all that good stuff. And we're going to use dimensional analysis. Now, as I mentioned before lunch also, you guys are going to be using this to death once you get to chemistry class, in high school, and in college. So this is a really nice start for you to get to see it kind of early on. Now, we are not going to do examples that are anywhere close to as complicated as the ones that you'll be doing in your future. So we're just going to kind of use some of the little ones to show you some of the more complicated ones later. And the first example that we're going to work says, a snail moved 30 feet in 2 hours. How many inches per minute did the snail move? Now, before we can get started, I'm going to activate a little bit of background knowledge. And I'm going to talk about fractions. So we've got the fraction 1/2. How come it's okay for us to multiply it by 4 over 4, get 4/8, and we can still say that, ooh, technically, this is still exactly the same fraction, 1/2 and 4/8. Somebody think for a second. I know you guys all know that that's true, but how do you know it's true? Morgan? Because all you're really doing is multiplying this by 1? What do you mean? That looks like 4 over 4 to me. That doesn't look like a 1. You're right. You're absolutely right. All you're really doing is multiplying it by a 1. Why? Why is that the same thing as a 1? Okay, 4/4 equals 1. Now, this is a big, giant, souped-up version of 1, but it's still just basically a 1. Anytime you have two amounts that are equal to one another, 3 divided by 3, still going to be 1. 2 divided by 2, still going to be equal to 1. Now, it's a bigger way of writing the number 1, but it's still 1. Well, we use this idea in what we call a unit multiplier. And it's basically just a fancy, souped-up way of writing a giant 1. So, for example, 12 inches over 1 foot. That's equal to 1. How come? Sure doesn't look anything like a 1 I've ever seen. Lexi, how come that's a 1? Exactly. 12 inches is equal to 1 foot. You guys have been told that amount since you were in, oh gosh, way into grade school. Okay, so technically, because you've got one equal amount divided by another equal amount, it's really equal to 1. Now, it's a big old souped-up version of 1 that's got a lot more letters and numbers in it, but it's still technically a 1. So we are going to go back to the example that we just used a moment ago to show you how you can use that idea of a unit multiplier to convert this. So we're going to convert 30, oh, let me get an ink that shows up better, 30 feet in 2 hours. So we are going to use a unit multiplier in order to be able to solve this. And as you might recall from a second ago, a unit multiplier is simply a big old souped-up fraction, basically. It's two measurements that are equal to each other, on top of each other, that really just equal 1. Now, one of the units, and this one's a little bit harder because we're actually going to be converting units of time and feet. There's no particular reason behind this. It really doesn't matter which one you start with. I always just start with the one on the top for no particular reason. Okay, now it says that we're going to convert it from feet to inches. Now, you've never actually seen a problem like this before exactly, but take a second and think to yourself, what unit multiplier might you use to convert feet into inches? Might look a little something like the one we just did. what unit multiplier, and remember a unit multiplier is just when you have two measurements, and it doesn't have to be length. It can be pounds, it can be time, but it's some kind of measurement where you've got two equal amounts that are on top of each other so that it basically simplifies down to 1. So if you just had to guess what unit multiplier you're going to use for this one. So we have an idea, Aaron? Absolutely. 12 feet, or oops, yeah, 1 foot, 12 inches. Okay, now this is where it gets a tiny bit confusing. Okay, so what you're going to do is you're going to multiply this by the unit multiplier. But I'm going to show you a little secret. You have to set it up. Well, it's not a secret, but a little trick. You have to set it up so that if feet are up here in the numerator of the ratio, feet have to be in the denominator of the other ratio. Now, by multiplying 30 feet per 2 hours, okay, I'm going to multiply it by 12 inches over 1 foot. Am I actually changing the value of the amount that's given to me in the problem? No. How come? Because 12 inches over 1 foot is really technically just a big old souped up 1. Right, it's just a big fancy way of writing a 1. Now the reason that I have to set it up so that if the feet were up here in the numerator, the feet have to be down here in the denominator. And once again, I'm going to activate a little bit of background knowledge having to do with fractions. When you guys multiply fractions, as those math minutes you guys love, so we do 1/2 times 4/5. You know how you can cancel the 2 in the denominator with the 2 in the numerator? Okay. And how, when you're multiplying fractions together, you cannot cancel going straight across. Like if this problem were 1/2 times 5/4, you can't cancel straight across. You can only cancel if one of the numbers is in the denominator, one of them is in the numerator. Well, it works the same way here. Our goal is to get rid of these feet and turn them into inches. So we got to get rid of the feet. And if you set up your unit multiplier so that the feet are down in the denominator and the feet are up here in the numerator, it's actually pretty cool. You can just cancel them out. Now, pay special close attention. Have I even touched the numbers? I haven't done anything to those numbers. Okay, I did not cancel the numbers. All I did was cancel the units. And as long as one of them is in the numerator and one of them is in the denominator, just like when we multiply fractions. Here I was able to cancel because 2 divided by 2 is 1, 4 divided by 2 is 2. I was able to cancel because one was in the numerator, one was in the denominator. Well, same thing applies here. Since the feet are up here, the feet are down here, I can cancel them. So those feet are officially gone, and I've changed my feet to inches. Now, what do I do with all the rest of this mess? Okay, we'll figure that out in just a second. Now, I got to use another unit multiplier because I want to change these hours into minutes. What unit multiplier might I use? And it's okay if we're just taking an educated guess right now because we haven't actually seen an example like this yet. So what do you think you might use, Aaron? Exactly. 60 minutes are equal to 1 hour. Because technically, I'm dividing two equal amounts by each other. Now, this is a big old jacked up, souped up 1, but it's still technically a 1. Okay, it's just a big fancy way of writing it. So now I'm going to multiply all of this that I've gotten so far by this unit multiplier. Am I going to have to make any changes to it right now? Can I put it in here just the way it is, based on the example that you just saw here? Can I put this in exactly the way it is now and just do 60 minutes in 1 hour? Think about that for a second. What did I have to do with the second one? I see a head shaking. How come I can't do it this way? Sydney, what am I going to have to change? Hours are down here in the denominator. Where are they over here? They're in the denominator also. Am I going to be able to cancel out and get rid of those hours? Nope. So what am I going to have to do? I'm going to have to flip it around. Okay, the 1 hour is going to have to be on the top, and the 60 minutes are going to have to be on the bottom. Because if both of the hours are in the denominator, they're not going to cancel. My goal is to get rid of those hours completely and leave behind the minutes. Now I can, because I can just cancel out the hours. Now keep in mind, I have not canceled out the numbers. All I did was cancel out the units. I did not cancel the numbers. So now I've got, and this is a great way that you can double check yourself. After you've gone through and canceled the hours and the feet, all I've got left are inches per minute, which is what I want up here, inches per minute. So I know I've probably set it up correctly. I'm going to get rid of this stuff down here. So after I've gone through, canceled out my units, there's also some canceling you can do with some of the numbers that are up there. The same way that you can cancel numbers like you did with a fraction. Oops. Where is it? There we go. It's the same way we canceled out numbers if one of them's in the denominator and one of them's in the numerator. Let's say I'm going to take the example I had a minute ago, and I'm going to add a third fraction. Okay, so before I canceled the 2 because 2 goes into 2 goes into 2 once, 2 goes into 4 twice. So then I had some canceling. Now, figuring in this third fraction, I've got some other canceling I can do. 5 goes into 5 once, 5 goes into 5 once. I've also got some other canceling I can do. 2 goes into 2 once, 2 goes into 6 3 times. So if you add another fraction, it still works the same way. As long as one number is in the numerator and one is in the denominator, you can cancel from something all the way over here to something all the way over there. So to make my math a little bit easier, I've got some more canceling I can do here. Because this 30 and 60 will cancel each other, because 30 goes into 30 one time, 30 goes into 60 2 times, 2 goes into 2 once, 2 goes into 12 6 times. Now look at how much, oh, still got a little more canceling I can do. Because 2 goes into 2 once, 2 goes into 6 3 times. So after all that canceling is finished, let's multiply straight across the top and see what we have left over. We've got a 1 times a 3 times a 1, which simply simplifies to 3. We've got 1 times 1 times 1, so it's just going to be 3 over 1. So we can't forget about our units. Inches per minute, which simplifies to 3 inches per minute. Okay, I know that was a whole bunch of steps to go back there and do all that canceling, so somebody in the room asked if we could see that again. So I just reset up the problem, and we're going to go through and do all that canceling again, just so you can make sure where that came from. So first of all, we canceled our units, because we have hours in the denominator, hours in the numerator, feet in the numerator, feet in the denominator. Okay, next, there are a lot of different routes that you could take to do this canceling. This 30 and 60 are just screaming out to me personally, so that's why I'm doing them first. Okay, so I'm going to cancel the 30 and the 60. 30 goes into 30 one time. 30 goes into 60 twice. So that's how I was able to do that canceling. Then I saw, ooh, 2 and 12 also have a common factor. So 2 goes into 2 once. 2 goes into 12 6 times. Okay, so that's all reduced down to a 1. That's a 1, that's 1, but I still got a 2 in the denominator here and a 6 in the numerator there. So 2 goes into 2 once, 2 goes into 6 3 times. Does it make sense where all that canceling came from? And you could do it in a whole lot of different orders. You could have done it, you know, you could have started with this 2 and the 30. Like there's a million different routes you could have taken. So now we've got 1 times 3 times 1, because you just multiply straight across the top. So 1 times 3 times 1 is all we have left, and that becomes 3. 1 times 1 times 1 simply becomes 1. So that actually simplifies to 3 inches per minute is what we have left over. Now, for those of you who are just completely baffled by the concept of canceling, I'm also going to show you another way to do it without having to cancel all of those numbers. Now, there's still no way to solve the same problem without canceling the units. You have to do that regardless. And remember that the way we can do that is because the feet are here in the numerator, and here are the feet in the denominator. Same thing, hours are down here in the denominator, hours are there in the numerator. So that's why I was able to cancel them out. Now, if doing all that number cancellation that I did earlier just really confused you, it's no big deal. You don't have to cancel the numbers. All you have to do is, that's just a strategy to make it a little bit easier for you. But you can just multiply straight across, just like you normally would with fractions. So I'm going to do 30 times 12 times 1, then 2 times 1 times 60. Don't forget about my units that are still left. I've got inches and I've got minutes. Then I've got 30 times 12 times 1, which will be 360. 2 times 1 times 60 is 120 inches per minute. And finally, that 360 divided by 120 simplifies to 3. So it'll be 3 inches per minute. So you could just multiply straight across the top, straight across the bottom, simplify it so that it's 3 inches per minute. For those of you that are still a little bit confused, don't worry. This is just one example. For those of you who are not in class today, this is all we had time to do. So, but then there's also, I'm going to attach some extra notes on Class Jump along with this one that has some video of some other teachers working examples as well. So maybe that might be a little bit easier for you to see somebody else work it. Also, I'm sure some people are sitting at home right now thinking, why in the world do I need to do all of that work? Because really, all you have to do is change feet into inches separately, then change hours into minutes separately, and do it that way. And so the answer I'm going to give you for now is that tomorrow we're going to be working some that are not quite so easy to work that way, and you're really going to have to do the unit multiplier way in order to be able to solve them. So remember, you just set up the problem, so 30 feet over 2 hours, which is what we had, multiply it by a unit multiplier. 12 inches over 1 feet, remember, it's just exactly the same as multiplying it by 1, because there are 12 inches in 1 foot. Same thing with the 1 hour over 60 minutes. It's really just a big, giant 1. And the reason I was able to cancel the units is because feet were in the numerator, feet are in the denominator. Just like when you're multiplying a fraction, you can cancel anything that shows up in the numerator and the denominator. Also, hours and hours will cancel. So, and then you can just multiply straight across if you didn't like having to cancel the numbers. But in addition to some other examples that are on the website, you can take a look at those, or you can just wait until tomorrow, and we'll be working a lot more of these. But hopefully this gave you at least a little bit of some background knowledge for